Okay, so again, we wrote down the first example, which is y equals x cubed plus 2. Right, and we noticed that the only component from this equation is the plus k, which just says if it's plus k, it's up k units. If it's minus k, it's down k units. This is plus 2, so we're going up 2 units. Okay, now we're about to graph the parent function, and we're about to graph the transformation. Okay, so your parent function, remember, it starts at the origin right here, 0, 0. So just like this. That's your parent function, okay? If it moved up 2 units, okay, so your parent function, your 0, 0 is here, well, it went up 2 units. So that's where you start. So it's right here. So you just start from here. My pen is going out. Okay, and that's your graph. Okay, if you notice it moved up 2 units. Got that down, Marcos?
Yeah, that's done.
Good. All right. Okay, go into the next example. Okay, we got example 2. We have y equals parentheses x plus 2 cubed. Okay, again, I want to know what the transformation is. And we're going to have the parent function, which is y equals x cubed. Then you're going to have transformation y equals x plus 2 cubed. Okay, so if we go back to our notes, right, the ones we just wrote, okay, we look at them. It said it's in parentheses, okay? So we look at our rules, right? The only one that talks about is in parentheses is right here, okay? And it says x minus h, or sorry, up here. If it's x minus h, that means it's going to the right h units. If it's x plus h, that means it's going to the left h units, okay? So it says x plus 2, right? So if it says x plus 2, that means we're going the opposite way, okay? I know we think plus means to the right. When it's in the parentheses, it means it's going to the left, right? So my transformation is left 2 units. Okay, left 2 units. And again, if my parent function starts at 0, 0, right, the parent function never changes, starts at 0, 0, and I got to move left 2 units for my transformation. So I'm here, 1, 2. I got to start my graph here. Okay? So I just move to the left. Okay, example 3. Y equals negative 1/2 x cubed. Y equals negative 1/2 x cubed. Okay. So if we look at our transformation rules, right? There's a whole number in front and a negative sign. Okay. So my first rule, if I'm looking at the negative sign right here, it says that it reflects across the x-axis. So you can just put, for the first one, you can put flip across x-axis. Okay, but there's also another transformation. That's not the only one. Okay, so there's a negative sign. There's also a whole number, or a, in front of the x. Okay? That means it's a vertical dilation. Okay? And if we're looking at it, right, it says that if this number is greater than 1, then it's a stretch. If it's not greater than 1, then it's compressed. Okay? This is not greater than 1. 1/2 is not greater than 1, so it's a compression. Okay? So the way you write it, right, is you write it is a vertical compression by 1/2. So you got it right. Vertical compression by 1/2. Okay. So now we have y equals x cubed, right? That's our parent function. So I'm going to graph that. Right, because it starts at the origin. Okay. And now we have y equals negative 1/2 x cubed. Okay. Remember, it's flipped across the x-axis. This is the one that's going side to side is your x-axis. Okay, so when you flip it, if you think about it, you flip this over the x-axis. Now this is going to be coming down, and this is going to be going up. Okay, so you're just flipping it. So it should look like this. And it's compressed by 1/2, so it's shrunk a little bit. Okay, honestly, I'm not the best artist, so like if you need to, you can use Desmos to check your like the graphs. You can graph it in there to check the comparison if you needed to. Okay.
What did you do?
So we flipped it across the x-axis, right? So if I took this part here, and this is your x-axis, so I flipped it across, it's going to be pointing down now. So I drew it down, and then this way flipped on across the x-axis that way. And then the compression is hard to tell, like drawing it, but if you go into Desmos, you can check it out. You can see how it's flipped. Okay, and we got one more example for cubic functions. All right, so you got y equals 2 times x minus 1 cubed minus 3. Okay, so we have multiple transformations on this one. Okay, we just go in order. So the first one we can notice is the 2 in front. Okay, remember if this is A, if A is greater than 1, okay, if A is greater than 1, then it's a compression, then it's a stretch. Okay, if A is greater than 1, then it's a stretch. So you got vertical stretch by 2, because it's 2. Okay, so that's the first transformation. Okay, then you see in parentheses x minus 1. Okay, remember if it's x, so x minus h goes to the right. So x minus 1 is 1 unit right. Okay, and then out here, this is K. Right? So we're looking at this again. Okay, so the first part we did was 2, A is right here, A. So you have A is greater than 1, it's a stretch. Okay, so we did vertical stretch by 2. Then you got X minus H, okay? X minus H means going to the right, 1 unit right. And then you got K, where it says minus 3, so you're going down 3 units. Okay, down 3 units. All right, so you have your parent function at the origin, never doesn't change. Parent function always stays the same. Then you got your transformation. Okay, so you're going down. This is the origin. You're going right 1 unit and down 3 units. So 1, 2, 3. So this is where your new point would be. Okay, and then you would draw your graph. And it's a vertical stretch, so it'll just be longer. This is bad, but it will be longer. Okay.